Question 57 says, for what positive real value of k, if any, is the determinant of the matrix there equal to k? Then we have this note, the determinant of a matrix with those variables equals a times d minus b times c. Looking at the answer choices, we have a couple numbers here in A and B that also appear in the prompt itself. Answer choice C is the product of A and B, and answer choice D is the square root of answer choice C. As far as the ACT math concepts involved in this question, superficially, it seems like it's about determinants and about matrices, but the other huge thing that stands out here is the fact that they've given us this note that basically explains exactly how a determinant works. For that reason, to me, this question falls into a category of questions that I call defined function questions. And I'll write that out up here. Defined functions. And this is just my label for this type of question. Essentially, defined function questions introduce a made up or sort of advanced symbol or operation, but then tell us exactly how that symbol or operation works. Now, one of the hallmark features of these defined function types of questions is that they tend to look pretty intimidating. And what's ironic is the fact that they all basically tell us exactly how the operation actually works. They all define it. So these end up being pretty easy as long as we see them for what they are and don't get distracted by the novelty and the unusual presentation of the question itself. So now let's go ahead and solve this question, and there are a couple of different approaches that we can take here as usual. The first approach that we'll look at is using a more concrete approach, and then we will solve it in a more formal way that involves setting up an equation. So I'm going to write out these approaches up here. So approaches, number 1, concrete. We're going to test out the answers. And number 2 is formal. We're going to set up equation and solve. With the approach of testing answers, I like to start out with a middle number and adjust accordingly from there. So we'll start out with 12 here, and basically we're going to just assume that 12 is the correct answer, and we're going to plug it back into the question and see if it checks out. So the question again was asking us for what value of k is the determinant of this matrix equal to that same value of k. So since we're assuming that 12 is the correct answer, we're just going to plug in 12 anytime we see a k here. So I'm going to rewrite this matrix, and we'll have 12, 4, 3, and 12. And we want to see whether the determinant of this is going to be equal to k, so it's going to be equal to 12. Well, now, if we don't know what a determinant is, or even if we do, we can just reread this note and see that the determinant of a matrix with different elements arranged in this order is going to equal to a times d minus b times c. Looking at the matrix we have now, we can see that the a is going to be this number in the top left corner here, and then the d is going to be the number in the bottom right corner. So a times d in this particular case is going to be 12 times 12, and then we're going to subtract the element b, which is the number in the top right corner here, which is going to be 4, and then we're going to multiply that by c, which is the bottom left number, which is going to be 3. And again, we wanted to see if this is going to equal to 12. Well, 12 times 12 is 144, and then 4 times 3 is 12. So we have 144 minus 12, which is going to be 132, and that definitely does not equal 12. So we can see that 12 is not the correct answer here. As far as the next answer to try, I'm not seeing any one that's more strategic than any other one because they're all less than 12. Like the square root of 12 is less than 12, and so are 4 and 3. So I'm just going to choose 4 here because it's right next to the 12, but it doesn't really matter. And just like we did with the 12, we're going to plug that 4 back in for k and check out whether it satisfies the question. So our matrix is going to become 4, 4, 3, and 4. And we want that to equal to k, or 4 in this case. Let's write out our determinant expression again. So the determinant, once again, was this times this, which in this case is 4 times 4. And then we're going to subtract the b times c, which in this case is 4 times 3. And we are hoping that that gives us our value of 4. When we do 4 times 4, that's 16. 4 times 3 is 12. And this is, in fact, true that 16 minus 12 equals 4. So we see that the number 4 does satisfy the question. All right, now that we have solved it in this more concrete way of testing out the answers, let's look at the formal way of solving this. For the formal way, we're essentially just going to ignore the answer choices and go ahead and set up an equation based on the variable k in the prompt. So we're just going to leave it as a variable in our equation. So the first step here is that we want the determinant of this matrix to equal to k. And we're told that the determinant is equal to this expression. So we'll just write that expression as our first step. So using the letter k, a times d here would be k times k, which is k squared. And then we're going to subtract b times c, which in this case is 4 times 3. And we are trying to set up this determinant such that it is equal to k. So we're just going to write k on the other side of this equation. Now that we've written this equation, we'd sort of want to take another step back and just ask ourselves again, what kind of concepts are involved in this particular equation so that we know the best way to go ahead and solve that equation. The biggest thing that stands out to me is that the highest degree here is a 2, which means that this is a quadratic equation. And when the ACT has quadratic equations, they often can be solved through factoring. So that kind of tells me that I want to look to somehow factor this quadratic. Generally, the first step in doing that is to set the quadratic equal to 0. So that's going to be my next step here. Just make this, I'll make this 12. And actually, I'm going to subtract over the k first. So it's going to become minus k. And then I'm going to make this minus 12 is equal to 0. And now this is in a form that we can factor the quadratic in. So we'll write our little parentheses here. And then at this point, we are looking for two numbers that multiply to get negative 12 and that add to get the negative 1 here, which is implied as the constant in front of this k. The two numbers that multiply to get negative 12 and add to get negative 1 are negative 4 and positive 3. So we'll write those there, and then we're going to write our k and our k here in order to get the k squared. And by the way, if this process of solving a quadratic isn't super intuitive or if you're rusty with it, I'm not going to really go into depth about how to actually do these in general on this particular video because it's beyond the scope of the video, but I'll link to some other resources that go into depth about how to solve quadratics because it is an important thing to be able to do on the ACT. Anyway, so from here we can get our solutions. Our solutions are just going to be the opposites of these factors or the negatives of them. So we're going to have one solution be k equals 4, and then the other solution will be k is equal to negative 3. And from that, we can see that there are actually two values of k that basically satisfy the question. But going back to what the question, how it was specifically worded, it says for what positive real value of k is this matrix equal to k. And of our two answers, only one of them is positive, and that one is k equals 4. So we get the same answer that we got originally when we were testing out the answers. Now that we've solved it in this more formal way, these wrong answers will make a little bit more sense. In particular, answer choice A is a very tricky one, and we can see why the ACT decided to put that there. When we were solving this the formal way, one of our last steps here was to factor this, and what we factored, or one of the factors was k plus 3, and the solution was k equals negative 3. So we can see how someone might mix these two things up or assume that this factor was actually the solution and go with 3. And it's very interesting that they included this answer here, and they do this type of thing on a lot of other questions as well, because it shows us what the ACT actually really cares about. If we think about someone who went with 3 here and how much math they actually knew, they basically did everything really well except for one small step. Essentially, they didn't get intimidated by the unusual, kind of unfamiliar presentation of this question. They even recognized that this was a quadratic that they could then factor, which is another step that is a really good step. But then, just as their last step, they mixed up the factor with the solution, and the ACT decided to give them 0 points for that answer. Now, the ACT could have decided to not include 3, and if they didn't include 3, then someone who had made that mistake would have realized that their answer is not there and would have been more likely to, go back and check their work and possibly get the question right. But the fact that they included it shows us that one of the main priorities and ways that they design the questions on this test is it's extremely detail-oriented. And this attention to detail from the ACT's perspective is just as important, if not more important, than actually knowing the formal math behind the solution. And for answer choice D, radical 12, one way someone could get that is if, when setting up their determinant equation in the formal way, rather than setting it equal to k, like we did over here, they set it equal to 0, then that would lead to D as the answer. So I'll demonstrate that down here. We have k squared minus 4 times 3, and we're going to make it equal to 0 instead of k. And that would be k squared minus 12 is equal to 0, which becomes k squared is equal to 12, which becomes k is equal to the square root of 12. And I think the reason that they were predicting that is because if somebody were to begin to write this at this point, they might recognize it's a quadratic equation or something and kind of skip a step and automatically make the other side 0, forgetting that it needs to be k. So that's why that answer might be there. As far as answer choice E, we saw that there was a value of k that satisfied the question. One thing I'll say about this answer is that sometimes students ask whether this type of answer is ever correct, and it is correct sometimes. And so an example of that from this particular test is question 20. So check that out for an example of when this actually works. All right, to wrap things up here, let's just write out what we ultimately needed to know. So I'll write that over here. And we saw that when we were doing this in the sort of concrete way of testing out the answers, really all we did was some multiplication and subtraction. And that was it. So just arithmetic, really, for the formal way, ultimately needed to know. Just multiplication and subtraction. And the fact that we ultimately only needed to know multiplication and subtraction on a question that looks like this, and that's question 57 out of 60 on a college entrance exam, really goes to show a lot of what the ACT is about. As we noted earlier when we were first reading this question, a lot of this type of question is just the presentation of it. It looks very unusual to a lot of people, and it also looks intimidating in a lot of ways. So they're sort of building in the difficulty in the presentation, as well as we saw after we solved it, they were building in difficulty in terms of how detail-oriented it is, in terms of including an answer that can trap you if you're not super careful or you make a small mistake. And in that way, this question reflects on a lot of other ACT math questions. As we know, the ACT can't test us on super advanced math. They're limited to relatively basic math. And so they have to come up with these various techniques. A lot of them are sort of psychological, as we're seeing here, to make the test more difficult. But when we are able to see through all that and we're aware of what they're doing, then we can be sort of calm in the face of this sort of pressure that they're throwing at us. And we can also remember always to be very careful when we're executing our solutions. And that leads to the final point here, which is that part of the reason why we talk about the different approaches that we can take in solving a question is that knowing these different approaches allows us and gives us a way to double check whatever approach that we do decide to take. So for example, if we had decided to do this in the algebraic way and got sort of k is equal to positive 3 accidentally as our answer, and we were aware of how tricky and detail-oriented the ACT is, and we wanted to check ourselves, what we could then do is we could then plug that back into the question to see if it checks out. And if we put 3 back into the question, we'd get 3 times 3, which is 9, minus 4 times 3, which is 12, so 9 minus 12, and that would be equal to negative 3, which is not equal to 3. So we could realize at that point that we had actually made some mistake, and we could either at that point go back and try to catch our mistake in the formal way, or we could resort to just plugging in the rest of the answers to see what actually worked. All right, so that wraps things up for question 57. Let's go on to question 58.